All right, now we're going to, be simplifying nth roots and solving equations with nth roots / rational exponents. And this will be wrapping up our introductory video series on rational exponents, nth roots, and radicals. Let's get into it. So in general, let's say we have some variable, it's raised to the nth power, and it equals some number. Well, in order to solve, we need to raise this to the 1 over n, both sides. And these, because of the power rule, becomes x to the n over n, and that equals c to the 1 over n. What's n over n? That's 1, so it gives me x equals c to the 1 over n. The other way to write this would be taking the nth root of both of these things. This still becomes x to the n over n equals some number to the nth root. This becomes 1, and that gives me x equals the nth root of c. These are equivalent statements. All the rules of algebra apply that get us to this spot here where we are either we have memorized the perfect squares, perfect cubes, etc., or we use our calculator to find the final answer. Let's try some examples. So here we have the fifth root of 32m to the 15th. So 32m to the 15th. What we want to do is try to write the coefficient in the variable portion, each of them, as a expression to the fifth power. Can we do that? Well, we can if we know that the fifth root of 32 is 2. And the fifth root of m to the 15 is m cubed. Okay. Oops, sorry, to the fifth. Then we can combine what we got going on here. So I really just have 2m cubed to the fifth because they're both raised to the fifth power. I can just smoosh them together using multiplication. And if we rewrite this as an expression with a rational exponent, that gives me this. I know it's a lot of parentheses, but I want to illustrate that this becomes 2m cubed raised to the 5 over 5. Well, 5 over 5 is just 1, so my final answer is 2m cubed. That worked out nice and neatly. Let's see if we try another example, it works just as easily. We have the fourth root of x to the 20th power, y to the 8th. Let's see if we can write these as expressions to the fourth power. Let's keep it under the radicand. I have x to the 5th raised to the 4th and y squared raised to the 4th, because 5 times 4, power to a power rule, 5 times 4 is 20, 2 times 4 is 8. Let's simplify it even further. And I have x to the 5th times y squared. This whole thing is raised to the 4th. Now, instead of rewriting and doing this step here, which is a little messy, I'm going to point out that we have a index of 4 here, and we have an exponent of 4 underneath the radicand. These essentially just cancel out, and I am left with x to the 5th. Oh, I stayed in red. Y squared. Something to, yep. Okay. So let's move on to solving equations. On the left, 2x to the 5th power equals 64. I still need to do what we've always done, isolate the variable. So I'm going to divide both sides by 2 because I have 2 multiplying times x to the 5th. This 2 cancels out, and I'm left with x to the 5th. 64 divided by 2 is 32. Then I take the 5th root. I wrote that a little too close together. These cancel, and I get x equals the 5th root of 32 is just 2. Not so tough. Now let's try this other example here. 5x cubed equals 320. I'm going to divide both sides by 5. These are very simple examples, but I'm just using them to illustrate what we do here. 320 divided by 5 is 64. Then I take the cube root Oh, I did right. Of both sides, these 3's cancel, and my radical symbol is gone. I'm left with x equals the cube root of 64 is 4. 4 times 4 is 16, times 4 is 64. So we're good. So that's it for this. All right, if you have any questions, you know how to get a hold of me, leave a comment. That's it. Have a great day.